Let's talk about data and consider some issues and some vocabulary which is closely related with data. Data can be corrupt. It can be corrupt for many reasons, because it has been obtained through censors, and perhaps there has been mistakes, perhaps because it has been transcribed, perhaps because there's been some intermediary operations on it. There are two big types of data corruption. One of them is undetected and the other one is detected. Of course, the more complex one is the undetected one, which might appear much later. And so the causes are failures both in the software and in the hardware. An important issue with data is that data can be inconsistent. What does that mean? That means that the world isn't deterministic, and that from the same hypothesis we may have two conflicting conclusions, which mathematically is something we don't like. But in data coming from the real world, this will appear frequently. Here's a small example. In this example, Bob is age 10, he likes school, and his country is France. He has obtained a D in mathematics. Davor, on the other hand, is also age 10, he also likes school, and his country is also France, but yet Davor obtained an A. So two different results. Now imagine an application, an AI prediction system, trying to predict the result in maths for children depending on their age, if they like school, the country they live in. How will they deal with this conflict between the two? Should we predict an A? Should we predict a D? Should we predict a B or a C? This is going to be a complicated issue. And solving it by just removing both Bob and Davor doesn't work. So there's a second lesson to be learned, apart from the word inconsistent, with this example. It is that whatever system we will learn from here, it will necessarily make mistakes, either on Bob or on Davor. A key word associated with data is the word biased. We use biased with an algorithm, we use biased with the result of an algorithm, but we can also use biased with the data. Data is usually representative of the past. We have only taken data from what has happened. And the past is full of prejudices. These prejudices, if we try to build a system that is going to learn from these data, will contain these prejudices. And machine learning will always just reproduce the bias that is in the data, unless, of course, we do otherwise. Let's see some elements of vocabulary. Data, as in big data. Big data is a key word that has been used for a long time. Perhaps it's also a bit of a buzzword. The idea behind it is, of course, there's a huge volume of data, and therefore a huge volume of the information. The second thing that matters with big data is that we want to deal with this data as fast as possible. So this is the principle or the idea of velocity. And the third issue is the third V, which is the variety or the scope of the data points. So we're not limiting ourselves to just one task or one type of data. Anyhow, big data is a term that is used to encompass the fact that there's huge amounts of data, that we want to deal with this data very, very fast. Data mining is another area which exists both in research and in industry. The idea is that we have got huge volumes of data, and we want to run some algorithms on this data to try and find irregularities, to try and find patterns, to try and find some rules we hadn't even thought about, and that may be of profit for something. So this is a hugely active field of research, slightly different from machine learning. Machine learning is probably trying to find one rule, whereas data mining is aiming to find a lot of possible rules inside a huge amount of data. Emerged from the importance of data over the past few years is the notion of data science. The fact of being able to look at this data, to analyze it, to extract information from it, all this is part of data science. It is a science which obviously needs computing, which needs mathematics, which needs machine learning, which needs statistics. And the goal is to extract knowledge from data.